We are for occurrence for Group 7 for the course of KIX 2006 Engineering Economics and Project Management. For our project, we choose food order system in University Malaya Cafeteria. Traditional food ordering system in university cafeteria can result in severe queuing, challenge, and inefficiency. So this project aims to identify the most cost-effective and efficient web-based food ordering system for implementation across university cafeteria. So the problem that we face are long queues, inefficient manual order, which cause the operational delays and reduce the customer satisfaction. So this web-based online ordering system enhance the queue management and ordering flow, increase the customer convenience and reduce the labor cost and improve service quality. So it also fulfill the sustainable development goals where it modernizing cafeteria operation and eliminate the paper use, supporting sustainable practices. There are two alternatives for food order system. The first one is the basic website system and the other one is the advanced website system. So the core functionality is the same, however, they have different style of order management, payment option, queue management, and the user interface also are different, which means that basic website system has to use numbering queue system with a simple HTML and CSS, whereas the advanced website system has the real-time order status with a responsive UI and UX. So the scalability also are different, where basic website system has low response, whereas the advanced website system has higher responsive system. As for the security, system maintenance, and the user experience, each type of the website also bring different styles, different functions. For the estimated cost, we have different costs for the staff, where we hire project manager, programming team, engineering economic analyst, quality assurance tester, technical consultant, webmaster, as well as the data analytic dashboard. So for basic website system, we have around total estimated cost of 52,500, whereas the advanced website system has total estimated cost of 72,000. As for annual charges, we have two packages for basic website system and advanced website system. For the basic one, we have the package of 3,099 ringgit, whereas the advanced website system has about 5,099 ringgit. We also include the hosting and infrastructure such as the web hosting, web pages, server, cloud service, security system, maintenance team, testing and feedback, survey tools, and the feedback incentive. All the total annual cost for basic website system is 24,506 ringgit, whereas for advanced website system is around 34,247 ringgit. For the annual benefits, since the basic website system has a payment upon pickup, so the labor cost saving is around 63,000, whereas for the advanced website system, it fully online payment system, so it has labor cost saving of 126,000. Besides that, we also save for the electronic cash register machine, paper and printing saving, operational efficiency gains, scalability, data-driven insights, as well as the electricity and sustainability. So the total annual benefits for the basic website system is 70,000, whereas for advanced website system is around 153,000. As for benefit cost ratio calculation, we take this website system for the useful life around 10 years with the minimal attractive rate of return of 3%. After we calculate the benefits, initial investment, and the operating and maintenance cost, O&M, we substitute the value into the equations and we will get 2.2831 for basic website system and 3.5842 for advanced website system. Since the advanced website system has higher conventional BC ratio, so we will choose advanced website system as our project. After that, we're doing the incremental BC analysis. For present worth of basic system is around 2.2831. As for present worth of advanced system, the BC advanced is around 3.5842. So using the incremental BC ratio formula, we will get 1.1316 for advanced and basic system. This so that advanced has higher ratio than the basic system and it can be implemented for Cafeteria.
The Cafeteria online ordering system project is structured into 6 major phases. The first phase will be planning, followed by designing, developing, testing, deployment, and then maintenance. This phase spans across about 14 weeks, ensuring a manageable and trackable development process. To coordinate task dependency, we adopted the critical path method, or in short form is CPM. This method focuses on identifying tasks that cannot be delayed without impacting the entire project duration. Activities like user interface design, programming, payment integration, and final testing are placed on the critical path. This timeline is visualized using a Gantt chart, which clearly highlights these critical tasks and their dependencies, allowing us to maintain tight control over project progressions. Okay, so for this slide, the Gantt chart helps map out the sequence of all tasks. Tasks highlighted in red represent the critical path, which is these must be completed on schedule to avoid project delays. Our project spans about 14 weeks, and the CPM model allows us to allocate human and technical resources efficiently. By managing this schedule precisely, we ensure that the development aligns with the academic calendar, especially given the cafeteria's operational timelines and testing requirements. Okay, for this slide, we will be discussing about the estimated budget outline for our project. The total estimated budget for about 12 to 14 weeks active development period is around 76,000 ringgit. Well, it is within our budget cap, which is 80,000 ringgit. Okay, let's break it down. The budget includes 12,000 ringgit for programmer wages, which will be hiring about 3 persons, and each will be paid for 4,000 ringgit, and then 2,000 ringgit for user interface design tools, and then 1.5 thousand ringgit for hosting and domain service, and then 5,000 ringgit will be allocated for the server maintenance. Hardware costs such as laptop and testing devices amount to 8,000 ringgit, with an additional 3,000 ringgit reserved for emergency replacements. We also allocated funds for user testing incentives, consultations, legal compliance, and training. About 10% contingency reserve, which is around 70,000 ringgit, is included to manage unexpected expenses without disrupting the project progress. Now for this slide, I will be explaining about our human resource allocation. So what it is a structure to manage the project's functional needs. On the top of the hierarchy is the project manager, the one who will oversee the entire workflow and ensure that our project is aligned with the goals. And below it, there are 3 teams. The first one is the technical consultant, which will be the one who provides guidance on tool set and architecture. Next to it is the engineering economic analysis, which will be the one evaluating the cost, efficiency, and return on investment. And lastly is the user interface designer, which will be the one who crafts the interface focusing on the usability and accessibility. Below it, there are 2 teams, which is the programming team and the QA tester. For programming team, will be working during the developing phase, which will handle the backend, database, and ordering system. And for the testing phase will be the QA tester, which will conduct the system testing and bug tracking. And below it is the webmaster, which is the one who will be in charge in phase 6, the maintenance phase, to ensure the system stability after the launch. So all of these roles is prioritized critical path tasks. For example, the most experienced team members are allocated to programming and integration phase, which are crucial for keeping the project on schedule.
For resources, we are looking at material resources like EBase 16 Plus or Pro for hosting, using shared or quarter racks for server, and relying on VMware Cloud. As for facilities,
We will either be working remotely or utilizing a co-working space, with testing conducted on borrowed device or in a dedicated IoT lab depending on the system's complexity. Our project timeline is set at 14 weeks, which is 6 phases: planning, designing, development, testing, deployment, and maintenance. Next, let's quickly review our project constraints. We are on a strict 14-week timeline with a budget shown in the table. Crucially, the system must include FBX or e-wallet payments and achieve 99.99% server uptime. We are limited to one UI designer and have no dedicated security team. Plus, we are tied to VMware Cloud and exabytes hosting. Now, let's address potential problems. For technical complexity like real-time payment sync, we will use webhooks. To manage our type programmer budget, we will leverage AI tools and freelancers. We are addressing staff resistant to digital queues with training at a hybrid system. Plus, we are ensuring data privacy by anonymizing data and isolating payment servers.
From this part, I would like to talk about what are the implications which can be achieved through our website's project. There are three main positive effects will be expected. First, quality improvement in organization, especially the cafeteria in UM. Second, the economic growth in society. Third, the improvement of data secure in ethics. Let's look at these 3 points individually. Let's look at the first point, the implication in organization. The main issues of the cafeteria is the long queue because of the inefficient ordering system. By a lot of hassles from this system, not only the customers unsatisfied with the services, but also the workers of the cafeteria cannot focus on their work, which will lead to poor quality. Our websites can solve this problem with the functions of queue tracking, quick payment, real-time order status, and more. It can reduce waiting times of the customers, and the workers can focus on their tasks. This will help the cafeteria to provide the high-quality services. Next is the implication in society. The dissatisfaction of the customers leads to less use of the services. It caused the sales declining, which means that the economics also stagnate. Our advanced ordering system can satisfy the customers and can contribute to increase the sales. By the increase of sales, it can expect the positive economic growth and enable society to generate the good economic circulation. This means that we can also achieve the SDGs, which will be a big progress to make the sustainable future through the technology. Let's look at the last part, the implication in ethics. The conventional basic system has the limitation with data security, and it wasn't enough to prevent the data stealing. Of course, we have already considered these points, and our system is equipped with the high security functions, which can diminish the dangers of data stealing. By using our systems, it can secure the user's privacy, and it's also helpful to keep the high standard in moral aspects. Last but not least, we highly recommend to install our advanced food ordering system. Through the analysis, it is obvious that it's worth enough to operate this system, and there are a lot of benefits as the long-term use. We can conclude our system is the user-friendly system, which can satisfy both users, the customers, and the workers, and can provide the sufficient food experience to everyone. This is all for our presentation. Thank you for listening.